Okay, so let's continue the Intro to Derivatives handout on number 5. And so for this one, it says arrange the following quantities in ascending order, so least to greatest. And the hint is to think of all 5 quantities as slopes. So when I say a slope of 0, well, I'm just saying a flat line, so something that looks like that, slope of 0. If I said slope of 1, that would be something that looks like this, right there. So then I need to figure out what these other slopes are. So f prime 2 would be how steep this line is at 2, or this curve is at x equals 2. And so if I drew a tangent line right here, that slope to me looks like it's a rise of 1 and a run of 2. So its slope, this f prime 2, is about 1 over 2, rise over run, 1/2. Let's look at f prime 3. So f prime 3 would go right here. And if I drew a tangent line, oops, sorry, let me make that a little bit better. Looks like that. And so I'd say this one looks like it's 1 over 1, 2, 3, 4. So this guy is about 1/4. And if you look at it, you can kind of tell it's got to be less than f prime 2 because the curve is flattening out here, right? So now we got one more to do, f of 3 minus f of 2. Now you could just subtract whatever you think f of 3 is and f of 2, but if you wanted to think of it as a slope, think of it like this. It's over 1, which is 3 minus 2. So this is y2 minus y1 over x2 minus x1. This is the slope of the secant through 2 f of 2 and 3 f of 3. So that's the line that goes right through these two guys. And if I look at this one, I'd say this is a rise of 1 and a little bit, 1, 2, and a little bit more, maybe 3 down here. So I'm going to guess that this one's about 1/3. So if I go least to greatest here, 0 is the least for sure. Then a 4th is next, so f prime 3. Then a 1/3 is next, f of 3 minus f of 2. Then a 1/2 is next, and then 1. So here they are in order. Okay. So let's go on to number 6. So here's f on the left side, and we're going to sketch the derivative of f. Derivative of f is really f prime x, which means the slope function of f. So what we want to do is we want to figure out all different slopes at these important points here. So at A, the slope is over 1, up 1, 2, 3, 4. So at A, I'll write it like this. F prime at A equals 4 over 1. Let's look at f prime at B. So we're going to have to do some estimations. So if I draw a little tangent line right here, looks to me like it's over 1, up 1. So I'm going to say at B my slope is 1. Oh, sorry. F prime at C, that should be easy. It's a flat line. It's a horizontal tangent right there, so that's a slope of 0. F prime at D. Let's see here. If I draw a little tangent line at D, looks like down 1 over 1. So this slope would be negative 1. And then at E, let's see here. Down 1 over 1 and a bit. So let's say, to make it a little simpler, let's say it's a drop of 1 over a run of 2. And then at F, F prime at F, that's 0 again because it's flat there. And then notice it goes, the F prime is positive again after that. So right here. So let's draw a sketch. So at A, so this graph over here will be of F prime. So when we're at A, which is x equals 0, we've got a slope of 4, so I'm going to draw F prime as 4 here. B is a little bit between 1 and 2. So a little bit between 1 and 2, I want my f prime value to be 1. So a little bit between 1 and 2, right there. At c, it's got to be 0, and c falls on 2. At d, d falls on -3 here, and the slope is -1. E is at 5, and so that's -0.5. And f is back at 0, and then it goes positive. Excuse me. So if I draw this sketch, it's going to look something like this here. And again, remember, this is not the graph of f. This is the graph of f prime. It's the graph of the slopes. So like if I said, what do you think the slope of f is around 4? You could look at this graph around 4, say, well, it's a little less than -1. You know, or it's right around -1. And if you look at 4, yeah, it's right around -1. Okay. Let's move on to 7. So in this one, they give you the graph of f prime. And what we're supposed to do is come up with a graph of f over here. So this is the original function. This is the derivative function. Okay, so one easy thing to do is f prime 0 has to equal 1. So f prime 0 is 1. So it goes through 0, 1. So since this graph on the left is f prime, and down here f prime is -1, we know that the slope of f is -1 from this x value to this x value. And we know that the slope of f is going to equal +2 for all of these values over here. So, and the place where they get split is at 1. So I need a slope of -1 from everything on the left side up to x equals 1. So that means that over on my original graph, I need a slope of -1 up to 1. So right here, and then just keep going backwards, -1 all the way. So it looks like this right here. And then once I get to 1, I have a slope of 2 going this way. So on my original graph of f, I need over 1 up 2, over 1 up 2, and I get this part of the picture. So notice right here, f prime equals 2 on this side, f prime equals -1 on this side. And right here at that weird corner, I can't draw a tangent line, right? If I tried to draw a tangent line, well, there are lots of different tangent lines I can draw. So that means that's why over here on the original picture, it's open for the derivative. The derivative is actually not defined, even though the function that I had, the original function I have, the f of x on the right side here, is continuous at that point. It's just not differentiable there. There's no slope at a corner. Okay, so let's keep going. When g is decreasing, what do you know about g prime? Okay, so g decreasing, let me switch to a lighter pen. G decreasing means that the slope of g is negative. And if the slope of g is negative, well, slope of g means the same thing as g prime. So g prime x is also negative. So g prime x is negative when g is decreasing. When g prime of x is positive, well, that means that the slope of g is positive. And so then that means g has to be increasing. Now when g prime is 0, well, that means that we've got a horizontal tangent. On g. So then I'm going to draw some quick sketches of these because some students sometimes get confused by this. G is decreasing does not mean that it goes to negative infinity necessarily, because you could decrease in different ways. You could decrease like this, right, where it has a horizontal asymptote of 0. It keeps going downwards, but not downwards to negative infinity. So you could have one like that. You could have one like this. And you could have one like that if you wanted. So there are lots of different ways to go to negative infinity. Or just to decrease. Just to decrease. When it's positive, same deal. You know, you don't have to start at negative infinity and go to positive infinity. You might increase like that. Or you might increase like this, where you increase with a boundary. And then for a horizontal tangent, you get these in a few different ways. One way would be like in the very first problem that we did in this handout, where it's flat just for a moment and then it continues up. So the horizontal tangent's right there. Or you could get it at like a nice smooth curve where you have a maximum right there. Whoop. Or a minimum, like right there. Okay. So we're on to our last problem here. We've got the graph of sine x, and we want to graph f prime of x. Now, you've actually done this problem in a video at the end of the last unit. But if I'm trying to graph sine of x, or the slope of sine of x, we can do it by analyzing the graph that we have here. Slope is 0 here. M equals 0, m equals 0, m equals 0, m equals 0. And I'll also tell you, right here, the slope actually turns out to be positive 1. So over here, you can probably guess, since it's symmetric, the slope's negative 1, and then it's positive 1 again. So if I were to plot those points as my f primes, so like if I made a little list here, if x is something, what's f prime of x? Well, when x was negative pi over 2, I got 0. When x was 0, I got 1. When x was pi over 2, I got 0 again. Remember, this is the same thing as m. F prime is m. When I've got pi, it's at negative 1. When I'm at 3 pi over 2, it's 0. 2 pi, it's 1. And 5 pi over 2, it goes back to 0 again. So then if I plot these things, well, it starts at 0, and then it goes up to 1, and then it goes back down to 0, and then it goes pi negative 1, and then it goes 3 pi over 2, 0, and then 2 pi 1, and 5 pi over 2, 0, and you can probably guess it looks kind of like this. And if you notice, here are the axes right here. This is the graph of cosine. So if f of x is sine, f prime x, whoa, f prime x ends up being cosine of x. So then if I do this one more time, some students guess, well then if I took the slope function of cos x, I'll get sine x back. But that's actually not true. So let's look at it. So I'll make another chart here. X, and then I want the slope of cos x. So I want the slope function of f prime of x. And the slope of f prime of x, or the derivative, let's say, so we get used to using that term. So the derivative of f prime x, what we call that is f prime x, take its derivative. So it's f double prime x. And so that just means the slope of cosine x now. So we're making a chart with double prime values. And so those are the slopes of the slope function. So right here we have a slope of 1, m equals 1. So when x is negative pi over 2, the second derivative is going to have a slope of 1. And then right here at x equals 0, we have a slope of 0. 0, 0. And then at pi over 2, we have a slope of negative 1. And then at pi, we have 0. And then at 3 pi over 2, we have 1. And then at 2 pi, we go back to 0. And then at 5 pi over 2, we go back to -1 again for our slope. So if we plot those guys, negative pi over 2 is at 1. So this is the graph of f double prime x. 0, 0 is right here. Pi over 2 negative 1's down here. Pi 0, 3 pi over 2, 1, 2 pi 0, and 5 pi over 2 negative 1. And if I connect these guys, you might be able to tell it looks sort of like this. And here are the axes. This is not the graph of sine. It's the graph of sine upside down. So this is actually the graph of negative sine x right here. Now I'll tell you right now, if you repeat this process and you found f triple prime of x, you'd actually get negative cosine x. And then if you did it one more time, and at this point you don't write 4 primes, you do this, a little parentheses 4, you're going to go back to sine x. And so then that means f of 5, the fifth derivative of x, will cycle back through to cos x again. And then it's a like a 4-part cycle. So it just keeps going from sine x to cos x to negative sine x to negative cos x. And then it cycles back around to here again. So this is if you take the derivative, you know, yeah, so each arrow means take derivative of, in this case. Okay, I hope that helps a little bit, and I'll see you guys sometime next week.